Demystifying sklearn's Dummy Regressor, a comprehensive guide. The Dummy Regressor in scikit-learn sklearn is a simple yet powerful baseline model for regression tasks. It doesn't learn any patterns from the data and instead relies on predetermined strategies to make predictions. While it may seem trivial, the Dummy Regressor serves multiple vital roles. 1. Establishing a baseline. Benchmarking. It provides a reference point for comparison with more sophisticated models. If a complex model performs only marginally better than a dummy regressor, it might indicate overfitting or limitations of the data itself. Understanding data. The performance of the dummy regressor can reveal insights about the inherent predictability of the target variable. For instance, a high accuracy score for a dummy regressor based on the mean strategy suggests that the target variable has little variation or that the features provided are not informative. 2. Evaluating model complexity. Overfitting awareness. A dummy regressor helps identify whether a model is overly complex in fitting noise instead of the underlying patterns in the data. Feature importance. A comparison of model performance against the dummy regressor can highlight the importance of features. If the performance difference is significant, it suggests that the features contribute meaningfully to the prediction. 3. Understanding model bias. Bias variance trade-off. The dummy regressor provides a way to assess the bias component of pay. Bias variance trade-off. A low bias close to the true value implies that the model captures the underlying signal well, while a high bias far from the true value indicates that the model is not capturing the true relationship between features and target. 4. Implementing simple solutions. Time-constrained scenarios. When speed is a priority and accuracy is not critical, the dummy regressor can be a valuable tool. Predicting constant values in certain scenarios. The target variable may be relatively constant, making a dummy regressor a suitable choice. Strategies offered by dummy regressor. The dummy regressor offers several strategies for making predictions, each providing a different baseline. 1. Strategy mean predicts the mean of the target variable for all samples. This strategy is suitable when the target variable has a relatively consistent mean value. 2. Strategy median predicts the median of the target variable for all samples. This strategy is robust to outliers and may be preferred when the target variable has a skewed distribution. 3. Strategy constant predicts a constant value specified by the constant parameter. This strategy is useful for testing specific scenarios or when a predetermined value is expected. 4. Strategy quantile predicts the specified quantile of the target variable for all samples. This strategy is useful for scenarios where you want to predict a specific percentile of the target distribution. Key parameters. Strategy string specifies the strategy for making predictions. Constant float. The constant value to predict when using the constant strategy. Quantile float. The quantile to predict when using the quantile strategy. Example. Python. From sklearn, dummy import dummy regressor. From sklearn, model selection import train test split. From sklearn, datasets import load diabetes. Load the diabetes dataset. Diabetes load diabetes. X diabetes, data. Y diabetes, target. Split the data into training and testing sets. X train, X test. Y train, Y test train test split X. Y. Test size 0.2. Random state 42. Create a dummy regressor with the mean strategy. Dummy regressor strategy mean. Fit the model to the training data. Dummy regressor. Fit X train. Y train. Make predictions on the testing data. YPRED dummy regressor. Predict X test. Evaluate the model. Print fr squared score dummy regressor. Scores test. Y test. Conclusion. The dummy regressor is a valuable tool for establishing a baseline, evaluating model complexity, and understanding the bias-variance trade-off. While not a predictive model in itself, its simplicity allows you to gain valuable insights into the characteristics of your data and performance of your chosen model.